Good evening, everyone. We formally start. I just start recording. Um, the today presentation will be by Professor Wu, and then, if time permits, Elena, we will start the walk through some important point in BigSQL. Before giving the word to Professor Wu to present the today topic, I want just to say a few words regarding assignment 2. The results are better than I expected because during these 2 weeks you've been doing the assignment, there were a lot of frustration, but at the end of the day, I think all this pay off. The results are very good. And let me tell you, there is no other way to learn all these big data services and analytical tool without investing a lot of time. So that, and it pays off. Let's put it this way. So some of you jumped directly to the assignment, didn't read some, skipped some of the instructions, some skipped some important instruction, the way to work in the assignment, and then they had to go back. So my first recommendation is read everything before starting the assignment. I just want to say that even though the required readings are quite extensive, you must read them before doing the assignment. Otherwise, you don't know what you are doing and why you are doing this. So this assignment was quite interesting. You did an application, analytical application, to analyze Twitter data using the power of two analytical services. One is Insight for Twitter, which provides you the data. It's not just the Twitter, the Insight of Twitter in Bluemix, and in-memory analytic power of DashDB to do the analytic. And you use two different methods to get insight of this data. And I focus mostly, as you see the rubric and the grading, to discuss as a data analyst the result you obtain. And this is the very important part of data analysis. So some of you spent a lot of time in the coding, lost in loading the packages, the R packages, with which in some cases could be avoided, and in the coding, and didn't get the big picture. That's why I try now to wrap up what was the assignment number 2. Second thing I want to say, we are using the services in Bluemix. This is IBM provided platform with a lot. You can see there are hundreds of services there. So regarding the technical support, your first technical support is the TA. It's not IBM. IBM doesn't have to go through the script you are running and find your what is going on. So if there is a pattern, in the service that something is not working properly, of course ticket is opened and IBM take care. But IBM take care about the service itself, not about our assignment, what of the script is working, what is not working. So please, let's work in the better and let's say the most effective way. We have very responsive TA, Linish and Yelena, and they are answering your question as soon as you pose them. No one can claim that he has a question for more than 20 hours without response. So that is the way to work. And if there is some issue, a repeated issue, which means not individual issue, then the TA can direct you to open ticket with IBM. Okay, this is the way we are going to proceed from here forward. And also I would like to say, if the TA is suggesting you, because sometimes there is individual problem which we cannot find out without sharing screen. If the TA is suggesting you to do Google screen sharing, take advantage and do it, and you will save a lot of time of frustration. So with no more, I'm giving, I don't know if someone has some comment or question regarding this, and we are moving to the new material for week 6. I don't see any questions. So, John Walk, you can start the today presentation, and then we will have some important points regarding BigSQL and question, if any.
Sure. Thank you, Professor Gorcheva. Hi, everyone. As you know, my name is Jong-wook Woo. I'm going to work with you from week 6 to week 11, mostly for about the fundamental of big data using IBM Bluemix and Spark data science experience. So as you see in this slide, I'm going to introduce big data based on Hadoop and IBM Big Insight. That has been popular for several years, and I'm glad that I deliver this content. So today's talk is mostly for about the history of Hadoop and what is Hadoop and what is big data, and what is IBM Big Insight for the big data, and for the Spark that we will learn later as well. So as you may know now, many companies and people have been meeting data issues because data has been growing too quickly. So these days, data becomes like terabytes or petabytes of data. That is because of a web. So web generates too many data. Also, there is a sensor data. No matter what you recognize it or not, we have too many sensors, including your phone. Sensor generate too much data. That is actually called the IoT, Internet of Things. Also bioinformatics, that includes your DNA data, and social media such as Facebook, Instagram. Many social media also generate data, also streaming data from your server or from your sensors, and also your online game and smartphone. Those data sources actually generate too much data. It wasn't the big issue before because data wasn't that big. So using the traditional approach, we can handle that. But nowadays, whenever the data becomes too much and too big, and also when data becomes non-structured or semi-structured, it becomes very hard to using a traditional approach. Simply, we can do that, but it is too expensive. You can handle those data with, for example, Oracle database, but you need to spend millions of dollars to handle those data. So we actually need a new system that is not expensive, but it can handle those large-scale data sets. So we have to remember what the fundamental of a computer, that is actually to store and compute data. Same thing for big data, that is actually massive data set or large-scale data set. We need a system that can store and compute them. So actually, Google is the company that met that problem than other companies or for other organizations, because they need to collect the data from the website in the world to collect, to actually crawl and collect the data set from the millions of websites. And also they need to store those data, and also they need to index them to make their search engine works well. So they had that issue. and Google knew that the traditional system couldn't store or compute those data sets. So they started building their own file system called the HDFS, that is actually Google Distributed File System, using non-expensive commodity computers, simply using the servers that people have been using. Also, to index those data, simply to process and compute those large-scale data sets, they have built the computing the service called MapReduce. That has been existing in AI, but they actually adopted it for process and index their data set. So based on the Google File System and MapReduce, they actually can store and process their massive data set. And actually, it is distributed parallel computing systems. And it's not expensive because they use commodity computers. I mean, the servers that we've been using. So simply, Google has a new supercomputers that is not expensive. The many companies, the government normally own a supercomputers that is actually distributed parallel computing systems, but they use too expensive servers for that, right? But Google actually adopt commodity computers to build their own supercomputers based on their own file system and their own the computing system. That is actually GFS and MapReduce. So actually, Google, once they successfully implemented their own systems, they actually published the papers around 2003 and 2004 to show up how they resolve that issues. And then, based on, motivated from those papers, open source community actually started the Hadoop project led by Doug Cutting. This gentleman is Doug Cutting that I took his picture at Strata Hadoop in New York. He's been working at Cloudera, that is one of the leading big data company, as a chief architect. He mostly focused on presenting his work these days. But anyhow, the Hadoop, this yellow elephant is actually the one of the solution for big data. And actually, this the yellow elephant is his son's toy. So when he started the Hadoop project at Apache open source community, he adopted his son's toy and put the name of this project as a Hadoop. That is actually the name of that toy. So Hadoop doesn't have any meaning. Some people thought Hadoop is like highly advanced distributed object-oriented programming something, but simply it is the name of the toy. So if we look at the history of Hadoop again, actually Doug Cutting, he worked at many Apache open source communities, mostly for search. So he started Notch. Actually, before that, he was in Lucene search engine, search API project as well. And then Notch is this extension that is for web search service. And then he thinks the Hadoop could be used for Notch. So he started the Hadoop project around 2004, motivated by Google's paper around 2003 and 2004. And then Yahoo hires Doug Coding to start Hadoop project more seriously. And around the 2007, actually, the Amazon cloud computing service was adopted by New York Times. Actually, the engineer named I think his name is Guthries or something, but I forgot. But anyhow, the New York Times used Hadoop and Amazon AWS, especially EC2 service, to successfully convert their image articles to PDF file with about $200 in one day. So that was a very successful and very famous example of how Hadoop has been used. And also Facebook launches Hive, that is another famous the Hadoop ecosystem. That is like competitor of BigSQL. So you're gonna learn BigSQL, that is by IBM, but Facebook Hive is one of the popular approach for data analysis in big data. So anyhow, it has been popular. So around the 2008, Cloudera started to lead the Hadoop project. And also after then, around the 2009, Hortonworks, another big data company, started this project. I mean, they joined the Hadoop project as well, spinned off from Yahoo. So Cloudera and Cloudera and Hortonworks are like Ubuntu or Red Hat over Linux. Linux is open source, right? And there are companies like Ubuntu or Red Hat that is to lead the Linux project. Similarly, Hadoop project is led by companies such as Cloudera and Hortonworks. And nowadays, many companies and many organizations adopt Hadoop for their big data solution to analyze and predict the data. So let's look at big data and think about the definition of a big data again. Big data is actually non-expensive frameworks that can store large-scale data set and also can process it in parallel. So the big data itself sounds like just data, but actually it is a platform to process it in parallel. So Hadoop is one of the popular solutions for big data. So it is actually open source, and you can use non-expensive commodity servers that you've been using. So once you adopt Hadoop with, for example, 4 servers, then you can actually own your own supercomputer. So these days, any small companies, any small research lab, even any small individual can own supercomputers. So let's take a look at the fundamental of Hadoop, starting with the HDFS, that is Hadoop Distributed File System, to store our data. So to store data, actually, the Hadoop has a block in Hadoop file system. Default block size is 64 megabytes, but the Cloudera and Hortonworks recommend to set Hadoop block as 128 megabytes. And then if you have a 1 terabyte data, that could be split into number of blocks, and those blocks are distributed into your Hadoop cluster. And also, these blocks have 3 replicas that are distributed into Hadoop cluster as well. So it maintains a fault tolerance. Also, Hadoop file system is the write once. It means that you can write your data into Hadoop system once, but after then, there's no way to update those data. So that's why it is called the write once. So mostly Hadoop is good for all labs. simply for online analysis processing and batch processing. Also, again, since block has a replication, it maintains durability and availability and throughput. Comparing to traditional supercomputer is not that good for fault tolerance, and it is mostly for processor intensive, not for big data. And also to process the data, same as Google, Hadoop has a MapReduce, and to maintain the resource of MapReduce tasks, actually Hadoop version 2 has a YAN resource manager. That is actually yet another resource negotiator. So it since this is distributed parallel processing, it should have a single master node and also many slave nodes. It's like one project manager take care of the project members. So project manager is like a master node called the resource manager, and slave node, actually the workers are a number of node managers. They can also generate application master for each application, and it is a data intensive computing. It means that since the HDFS and MapReduce resides at the same server, it means that when data is ready, the processor can process the data in the same server. So it is called the data intensive computing. That is different from traditional supercomputer. That is actually processor intensive computing. So traditional supercomputer is not good for big data because it has a bottleneck to read the data. But anyhow, the MapReduce, Hadoop system is good for batch processing and good for fault tolerance. Also, it has a concept of speculative execution. That is very important concept. So when you have many MapReduce tasks run together in parallel for number of different data blocks, maybe one task couldn't finish the process of a single block while other tasks successfully completed all the block processing. That single task actually caused the performance issue. At the moment, all other tasks, some like 2 or 3 tasks that completed their own tasks, can take over that task that didn't complete to finish that task. So simply idle tasks take over the busy task's job, and any task that completed that task should be the winner, and the other tasks can stop their work. Simply the one winning task can complete processing single block data, and its result should be accepted. That is actually called the speculative execution. For Hadoop distribution, you could, simply suppose that you have 4 servers. You could install Hadoop to make those 4 servers as a single Hadoop cluster. You could simply download Apache Hadoop from Apache Hadoop website. That is actually called the vanilla Hadoop because it is like pure Hadoop, but it's really hard to install and manage it. However, like a Red Hat over Linux, if you go to the website of Cloudera or Hortonworks, you can download their own Hadoop versions such as CDH and HDP, and it is very easy to install and manage it. And they are all free as well. And also these days, the cloud computing services are become popular to adopt this big data. I mean, to adopt Hadoop systems such as IBM Big Insight and Amazon AWS and Microsoft Azure HD Insight. And that is another the good approach to use Hadoop, because you don't need to even install it. It's already there, right? So in IBM, especially in Bluemix, there is a big insight that you could try to run Hadoop to use Hive and Spark and Pig. But especially for Spark, I mean, you will see how it works through the lab tutorial. There is a IBM data science experience that is migrated from IBM Bluemix that we will see later. So anyhow, Hadoop has been evolved a lot these days. So there are many Hadoop ecosystem that is built by many companies, and such as Facebook and Yahoo. They actually donate this Hadoop ecosystem to Apache open source community, so you can use it. You can use them all free. So, for example, for data analysis, Hive Pig have been popular, and then for interactive SQL, there's an Impala, Tez, and BigSQL, and BigSheet, and Spark SQL. And we have an example for BigSQL and BigSheet, right? That you could work from week 6. Also, for streaming data, there is a ecosystem called the Storm, From, Kafka, and Spark Streaming. Also, for data migration with the RDB and data warehouse, such as DB that you have learned, there's a Scoop ecosystem. And also for in-memory processing, simply there's a Spark Core and Spark. Every other Spark that we will see later when we started Spark. So if you look at the Hadoop and Hadoop ecosystem, actually Hadoop has the core that is Hadoop distributed file system and MapReduce, and then you will see the Apache Hive, Mayhouse, Q, and Apache Uzi for scheduling the resources and workflow. Also Scoop, and also there's a NoSQL DB called the Apache HBase that is running on Hadoop file system as well. So those are the Hadoop ecosystem. Again, those ecosystems are built by many companies, because when Yahoo or Facebook adopted Hadoop cores, they feel like they need more. They need more convenient functions that they could add. So that's why they started building Hadoop ecosystems such as Hive and Pig on top of a Hadoop core, like a BigSQL. So for Hive and Pig, that is good for data analysis in Hadoop as a Hadoop ecosystem built by Facebook and Yahoo, respectively. Since it's really hard to write a Hadoop MapReduce code in Java, so like a Facebook and Yahoo thought we could build the SQL like a service or script like a service to make the MapReduce coding much easier. So Hive and Pig Latin came. So anyone who knows SQL or simple script could write a MapReduce code. Actually, it is not MapReduce, but it is translated into MapReduce tasks automatically once you build SQL-like syntax, like a BigSQL. If you look through BigSQL near soon, you will see that is almost same as the SQL. So once you know SQL, you can write a SQL code and then run it on Hadoop. And also the Hive and Pig, they are running on MapReduce, that is batch processing, so it's not interactive. It means that even small SQL, even any small and short SQL, you need to wait at least 20 seconds to see the result. But BigSQL, like IBM BigSQL or the Hortonworks PAS or Cloudera Impeller and Spark SQL, they are much faster. So whenever you run the SQL, you can see the result in a few seconds. And this is kind of a logical diagram how you can build a Hadoop cluster. So in this example, there are like 9 servers and one like a server that is to manage and monitor those 9 servers. And through web browser, you can access, for example, Cloudera Manager or Hortonworks Embody to monitor the Hadoop cluster to see how much memory, how much resource, like how much CPU have been using for what Hadoop system or what Hadoop ecosystems. But mostly, if you have four commodity servers, you could build your own Hadoop cluster. But if you have your own laptop computer that has about 8 GB memory, that is normally not good enough to be a Hadoop cluster. Also, the IBM, because we are using IBM Bluemix and IBM Spark Data Science Experience, the IBM has its own the Big Insight and Stream. Big Insight is actually Hadoop cluster, and streaming is for taking care of data streaming. And on top of that, it has its own. It has its own ecosystem as well, such as BigSQL and BigR. This is what you can build it in your own data center, but you may want to use Bluemix. So again, IBM Big Insight that has been improved a lot these days. So it has the Hive, Pig, Spark, plus for data analysis, it has its own BigSQL and BigSheets. And also for it includes BigOwl and text analytics for predictable analysis as well. So simply using the IBM Bluemix, you could adopt Hadoop and NoSQL DB such as HBase, plus for predictable analytics, you could use Spark and BigR. And also, you could do text processing by integrating with the Twitter sentiment service and many other services from IBM Bluemix, including Watson as well. So if we think about the big data analysis flow, for data collection, you could use streaming data from Twitter using Kafka Storm or Apache NiFi, and you could just download the open data from government. And also you could use API from Yelp and Google and Siri Search, etc. And then you can store those data into your Hadoop HDFS or Amazon S3 or object storage of Bluemix or Microsoft Azure. Or you can even store those data into NoSQL DB, include the Couchbase, HBase, etc. And also for data filtering, you could use Hive Pig because you need to clean or filter data, dirty data, right? And then you need a data analysis or data science that is actually predictive analysis using Hive, Pig, Spark, BigSQL, and using even BI tools such as DataMia and Click. And then you could do data visualization using the existing BI tool and Excel, Power View, right? There's just the line here. There are 3 lines because I want to show you this area. This area is actually for data engineering. In industry, data collection and data storage and data filtering are the area called the data engineering and data analysis. And next area is data analysis. And then for predictive analysis, there is an area called the data science. And actually in data 650, we are covering all of these 3, right? Data engineering, data analysis, and data science using many different tools, right? Also, data visualization is another important area because even though you spend like 2 or 3 months to write a code, no one recognizes it that much. But if you spend like 2 hours to visualize your insight, that becomes very, very attractive. So data visualization is very, very important as well. Okay. So this is again the architecture and platform of the IBM cloud computing. So if you look at this, there's a Hadoop that includes MapReduce and the HDFS as well. And there's also streaming data using the IBM streaming service. So you could collect many data in real time. So that could be streaming data from sensor and from log file. And it can be stored into warehouse, or it could be stored into actually Hadoop file system. And then you can collect the data from social media and from your smartphone, etc., to store into Hadoop file system, and you process it. And then using Hive and HBase, you could analyze it. And then you can directly use the function of data warehouse to generate a report or to use its predictive analysis tool, or to use its visualization tool as well. But the data warehouse is too expensive, right? So instead of storing data into data warehouse, you can store many data into Hadoop file system, and then some of the hot data could be stored into data warehouse to generate a report or the visual chart. Okay? So there are many approaches to integrate the Hadoop and existing systems to save the budget. So actually, this is I just want to introduce what Hadoop and what BigSQL and what is the IBM Bluemix and etc. Do you have any question? Does anyone have any question? I've been working on this big data for about 10 years. So this is a great chance for you to ask me any question about big data, Hadoop, or Spark, or the cloud computing.
I guess they haven't started reading, still not in deep in the material, and questions are not coming. Just to let them think about, because since we are here, this is good opportunity. I will get 2 minutes from you to give them some instruction. We'll get to share my screen, if you don't mind. and
Sure.
then return to you. I'll get it. Okay. Let me share. In the meantime, if someone has question, either can put the question in the chat or write or unmute himself and ask the question. For some reason, some of you, since are not going to the classroom every day, are missing the logical flow, the way we deliver the stuff. So I suggest the following. Since we are constantly updating, posting assignment, you not only have to scroll down, but you can go to show all announcement and see what happened before. Okay, so you don't miss anything in the last, let's say, 5 days you haven't been in the classroom. Secondly, when you go to content, make sure you scroll down all the way, because look how the assignment is in almost at the end. I mean week 6, which is the actual week we are in class today. And you see the walkthrough is out of the assignment and the script is out because there are some restriction in lieu which don't permit us to put everything in the assignment folder. So that's why I'm clarifying that you have to scroll down, of course, read the required reading before going to the instruction of the assignment, and then, if the time permits, go to the recommended reading. In order to get full advantage of this class, I would suggest you do as much as possible of the recommended reading also. So don't jump to the assignment and go an overview and follow the instruction in the announcement area. So I saw some question here. Let's see in the chat if I can answer, if it's for me or for everyone. John Wong, I will give, if there are no questions related with this, I see several questions in the chat. Do you see them? John Wong?
Let's see.
Yeah, they are questions in the chat. Can you open the chat?
Some reason I don't. Oh, I see that. That is.
Okay. Yeah,
that is
they
in the
are.
below.
So I will give you to share your screen if you want answering the question to stop to show something. I just wanted to use the time until the question are coming. That was
Okay.
exactly my intent. I didn't
Sure.
want. So I don't see you now to give you the ball where you are. Oh, you are far away. Okay. Okay. Got it. It's coming now.
So maybe. Can I talk, or you want me to write down the answer?
Yeah, sure. Go ahead.
Okay. You know, Davis, the most challenging part is actually, it's really hard to find out the data these days, because data is the value. So people hide the data or they sell it. So especially in academia, you need to find out data to adopt a big data, the platform or coding to find out some insight or to predict analysis, but we can only find out the public data from the government. That is one thing. Another one is it's really hard to find out good Hadoop engineers, because you guys are in actually wrong area. It means that IT industry is moving too fast, so companies are leading it. School always need to follow that. So the faculty members and students, we always need to study something every day. If not, we become behind it. So that is another hard part. So first-time users, again, at least if you are in this data 650, you can learn. You are actually exposed to the Hadoop and BigSQL and Spark that are most popular terms these days. So once you follow the direction and tutorial, at least you know how to use that. And you know how to use cloud computing, such as IBM Bluemix and data science experience. Exactly. The shared tutorial, that is a step-by-step tutorial. So I'm pretty sure you know something about this. But again, school can provide you the fundamental concept and idea, but you actually need to use that in real world. You need to build something by yourself or for your project in your organization. That is the only way to improve your skill set. So that is actually a good question. So anyone have any other question here?
Please pose the question to everyone. No private question, please. Well, it can be private, but if it's for everyone, yes.
Jerry, that is a good question, but it depends on your skill set.
Exactly. He was sending this to me, and I said, that's not a private question, so talk to you. That question actually doesn't have answer, let's put it this way.
But if you are good at SQL, you can immediately adopt Hadoop, BigSQL, Hive. It may take maybe just 2 months if you focus on, assuming you know the SQL. Oh, Davis, we put all our preferred materials in the course website. So you could use that. And also, the many companies like Databricks, Hortonworks Cloudera, they make a profit by delivering the training. So they don't share those materials. So materials like training materials are value as well. So again, the Data 650, this is great course that you can take many materials that you like. Cool, thanks. Anyone have any other question?
Until they are thinking about question, I want to clarify two different, very important aspects because when we talk about Hadoop for more than 10 years, like big data, sometimes we get, let's say, sometimes we are not focusing in what is important for us. When I say for us as a data analyst. So Hadoop, many different professionals are working with Hadoop, let's say this way. If you are a developer, you are looking to Hadoop from other point of view. If you are data analyst, data scientist, you are looking to Hadoop ecosystem because, as was explained, this is not a single product. This is an ecosystem with many different material. From data analytics point of view, you look to this platform as the way to make your life easy to get insight for big data, because Hadoop distributed file system is the part of the component which will store big data. The big data you cannot store in other place. And then you have this processing power, distributed parallel computing with low cost, scalable, which is going to process your data. But as a data analyst, you are not in this lower level. This lower level is for developer. You are looking above that, what is Hive, BigSQL, to manage your data and to connect them to another analytical tool to get insight for this data. So that's why I want to clarify when you ask how much time I need to master Hadoop. I mean, I would say it depends. You want to learn and to be mastering all components of Hadoop, you will need a lot of time. You need just to manage your data. On the other side, you need to just manage your data as a data analyst. Maybe in 5, 6 weeks with good skill in SQL, you are already okay to produce something. So the question depends from which point of view you're looking to Hadoop ecosystem. Now, if you need to do MapReduce programming work, first you need Java skills. So this is beyond the interest in this course and in the program Master of Science with Data Analytics, because mostly these are type of job we don't have, let's say, the time and the profile in our program to go to MapReduce work. We are going to something which is more, let's say, more advanced, because Hadoop is, let's say, the first product which was wonderful until tools like Spark appeared and can do more efficient work for data analysts, for managing and getting insight. As a data scientist, getting insight from big data, the next generation tool is Spark, and this is which we are moving after week 7. So why we even are doing Hadoop in this class then would be the next question, right? Because for 10 years, many companies invested in Hadoop ecosystem. So we don't know where you are going to get your job, and it's important to have the minimum skill to manage big data on Hadoop. That is the point we are trying to learn and to get some knowledge in this class. Um, Jumbo, if you want, you can continue.
Yeah, actually, Davis is asking a really good question continuously. The Hadoop MapReduce has been replacing by Spark because of like its bottleneck and batch processing, and the Spark is in-memory processing that is like 10 or 100 times faster than Hadoop MapReduce. Plus, it is a lot easier to write a code than MapReduce, because MapReduce you need to use Java, and it is very complicated. But you know, Hadoop file system HDFS is too good, and it is already dominate the market. So Hadoop cluster is actually accepting Spark. I mean, Spark is integrated into Hadoop cluster for data processing. So Hadoop and Spark is actually integrated together. And any other question? Yeah, again, this is a good chance for you to ask any question. So just feel free to ask me any question.
In the meantime, Elena, do you have any suggestion? You had 2 points to remind them, very important. Can you speak, please? Until
Yes.
they think about other questions.
Yeah. So guys, this is very, very extremely important. When you write in your code, right, do not use any Microsoft products. Do not use Microsoft Word. Do not put your code in Microsoft Excel and so on, because some bad special characters get introduced and then the code stops working. One example would be Microsoft Word quotes. The SQL just does not like that, and it's very difficult to fix. Some characters you cannot really see. So never use Microsoft Word for the SQL. And I keep saying that, but somebody always does it every semester. So just remember. And another important key point is that do not use the back button when you're on the cloud. Never use back button. Use menus. Okay. So promise me you won't do that, right?
Yeah. Oh, another suggestion pop up. Some of you had a hard time with the first assignment in the cloud, which was assignment number 2. So you have to keep eye in all the buttons you have in your interface, because if you start loading a package and the package is not loaded and you click again, because you think something happened. This is like, think about operating system. You are put at some point, the system is gonna go to deadlock because you're continuously initiating a new process before the previous one has ended. So keep in mind, sometimes all these are new interface. I know all we have a hard time getting used to any new interface. You have to invest a little time and make sure you understand what is working, what is in process, and if it stopped, then initiate another process. This is very important. This is very important, and moreover in the cloud.
And I was going to tell you something, guys, about the Leo. What you could do is, if you go to your profile, there is a setting where you can set the notifications, and it's possible to. There is a setting where you can set to receive an email when the new announcement is posted. So if you look into that, go to the click on your and upper right, click on there, and then you'll see the settings in your profile. Then select the notifications, and you'll see. You can choose to receive an email when there is an announcement. So that way, if you are not visiting Leo on that day, you'll have a copy of the announcement. Or at least it will remind you to look for an announcement. All right?
Here is a question: why we are returning to SQL if this was in 620, and why now? And I think that was the main point. John, what do we want to answer this question?
Yeah, you know, the big data, the community always adopt SQL because the SQL is very easy but very powerful, and many people already know SQL. That's why the Hive, BigSQL, Impala, even Spark SQL, those ecosystem try to adopt the SQL syntax. It is not 100% matched with the traditional SQL, but still it's like 90% matched with the traditional SQL. So anyone who knows SQL can easily move on the Hadoop. That is the point. Yeah. So when you look through the BigSQL, you will see how easy it is because you know SQL. And now you even, the completing the tutorial and assignment, you now have experience to use BigSQL, and Hadoop and big data. That is the purpose why we have this example. Did I answer your question, Davis? Cool.
And that was not the story, let's say 5 year, let's say in the beginning when Hadoop appeared. You see the Hadoop, well, the presentation, you saw how many components in the Hadoop ecosystem. But the tendency to use, and why different tool appeared? Just because uh, only MapReduce work with Java is very hard to solve all analytical problem, and all the company move and develop some product which is SQL based, and that's why we are going with the flow to manage your data. Instead to build new skill, which is very difficult, we use the SQL skill, which are very wide available, not only we in our program. This is just because the industry has developed, let's say, this type of tool for the Hadoop ecosystem. And for Spark also. So this is the tendency. It's not just change. We had this in 620 and now in 650. So I guess this makes this more understandable. Do you see more questions? I don't see more question. If there are not more questions, there is no reason to hold up the meeting. We are to save time and to use wisely the time. So let's see.
Yeah, guys, I was going to say that if you have SQL questions, I just want to tell that I'm very good at SQL because I have DBST degree. So you're more than welcome, and I'll help you and I'll give you advice.
Also, I want to tell you, for those of you who doesn't have good SQL skill, let me share the classroom and show you where you can find, because where you can find a lot of resources if you need to reshape your SQL skill, because all big SQL skill for whatever all big SQL skill are based on your basic SQL skill. Even though it's not ANSI, this is the classroom, right? And in addition to each week material, we have several modules which are SQL resources. You can come here and it's full of resources which will permit you to reshape your skill. The same is for Python. The same is for RStudio. So if you need to reshape your skill, don't hesitate to use. That's why I'm saying to get more from this course. Any other question? I don't see more. Well, if there are not more questions, I don't know. Oh, is the question is discussion 2 grades? Well, just I graded assignment 2. I will get break, and over the weekend you will get the discussion grade also by Monday, because the assignment 2 was quite extensive to get graded. Thank you. By Monday you will have the grade of the discussion. Any other question? Okay, guys, if no more question, I stop recording